Hi, welcome to part 15 of the video series about vertical projectile motion. In the previous videos, we have solved an example where we have seen how to draw acceleration, velocity, and position versus time graphs. In this video, we are going to solve one more example regarding the graphs in projectile motion. But now, instead of drawing a graph, we will learn how to interpret it. A small ball is dropped from a height of 2 meters and bounces a few times after landing on a cement floor. Ignore air friction. The position time graph below, not drawn to scale, represents the motion of the ball. Use the graph and determine the time that the ball is in contact with the floor before the first bounce. The ball falls from the height of 2 meters and hits the floor at time t is equal to 0.64 seconds. Then it bounces off the floor at time t is equal to 0.67 seconds. The interval between these 2 points is the time when the ball was in contact with the floor. The time of contact can be calculated by subtracting these 2 points, 0.67 minus 0.64. The answer is 0.33 seconds. In the second part of the question, it is asking to determine the time it takes the ball to reach its maximum height after the first bounce. As it was mentioned in the previous part, the ball bounces off the floor for the first time at time t is equal to 0.67 seconds. It moves upwards and hits the floor again at time is equal to 1.90 seconds. We need only to calculate the time it takes to reach the maximum height, which appears to be exactly half of the time the ball spends in the air. Delta t is equal to 1.90 minus 0.67 over 2. The time it takes to reach the maximum height after the first bounce is equal to 0.615. The answer rounded to 2 decimal points is equal to 0.62 seconds. In the third part of the question, we have to determine the speed at which the ball leaves the floor after the first bounce. We already know that the time it takes to reach the maximum height is 0.62 seconds and that the velocity at this point is equal to 0. Hence, we can use the formula V final is equal to V initial plus A times delta t to calculate the initial velocity. The final velocity is equal to 0 and gravitational acceleration is minus 9.8. On the graph, the initial position of the ball is positive 2 meters. The ball is initially above the floor. According to this information, we can deduce from the graph that upwards is chosen as the positive direction. This is the reason why gravitational acceleration has a negative value. As we know, it's always acting downwards towards the planet. The time it takes to reach the maximum height is 0.62 seconds. The velocity at which the ball leaves the floor after the first bounce is 6.08 meters per second. In the last section of the question, we are required to calculate the time t indicated on the graph. But not much information is given about this last section of the motion. Still, by looking closely, we can pick up some pieces of information that can help us solve the question. First of all, we know that this part of the graph represents the maximum height the ball reaches after the second bounce. Also, we know that if it takes time delta t to fall from the maximum height to the floor, it will take exactly the same amount to reach the maximum height. To calculate delta t, we can use the formula delta x is equal to the initial times delta t plus 1 over 2 times a times delta t square. According to the graph, the maximum height the ball can reach during the second bounce is 1.2 meters above the ground. Afterwards, it falls to the ground, which means its displacement during this section is 1.2 meters downwards. It's known that the velocity of the ball at the maximum height is 0, and gravitational acceleration during free fall is 9.8 meters per second square. The time it takes the ball to fall on the floor from the maximum height is 0.49 seconds. By adding twice this value to 1.97, which is the time the ball bounces off the surface, we can calculate the time t. It is equal to 2.96 seconds. In this video, we have solved an example that helped us to interpret position versus time graph of a ball making vertical projectile motion and bouncing off the surface. In the next few videos, we are going to solve some examples to understand the entire topic better. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.